Hello everyone, I'm Oscar Karnalim from University of Newcastle, Australia, and also from Maranatha Christian University, Indonesia. On this occasion, I will present my paper entitled Promoting Code Quality via Automated Feedback on Student Submissions. First of all, what is code quality? So code quality is the clarity of the code to be understood without the need to test the code or read its documentation. Although code quality is a serious concern in industry, it is not the primary focus in academia. So, as part of the solution, this work in progress proposed Code Clarity Suggester, or CCS. It is an automated feedback tool about code quality that is embedded to an assessment submission system. So basically, each time a student submits their work, they will automatically get feedback about the code quality in an HTML page whose URL is emailed to the student. So this is how the feedback looks like. So on top left, we have general guideline about code quality. After that, we can see our submitted program with some low quality code segments highlighted. We can see also all of the suggestions on the top right in the table. And if you want to go further to check the detail, we can click one of them and then the information will be displayed on the bottom right. For this initial study, we have 5 suggestions. First is to correct misspelled words. Second, to rename identifiers that are either too short or not meaningful. Third, to rewrite comments that are either too short or not meaningful. Fourth, to ensure that all identifiers consistently satisfy a particular naming style, either capitalization or underscore. Lastly, we check that each code block has a comment. We also have 3 research questions in our initial study. First of all, is there a role for the tool when the students are already encouraged to write clear code? So basically, we measure the proportion of low-quality code fragments in programming assessments in a course where a high code quality is encouraged as a part of the grading process. The dataset covers 16 assessment tasks with a total of 745 student programs. We found that some code parts are in low quality and the proportion is quite substantial, around 10%. So we can say that CCS still has a role as a reminder, since some students might occasionally neglect to follow the guidelines. For the second research question, what are the expected false results for spelling corrections? So we manually observe corrected spellings for both identifiers and comments in the same dataset for research question 1. The false results are, first, abbreviation. For example, KPS, which means kilometers per second. The second thing is contractions. For example, nums means numbers. Third, concatenated words without delimiters. For example, data points without a space. Next is programming terminologies like to do, which means something that needs to be done. Also, there are named entities like student names, website domains, or even programming products. Last but not least, the combinations of the above. For example, like TARG, which means target argument. For the third research question, we ask how effective is the tool to educate students about code quality. So we performed 2 quasi-experiments involving 2 academic semesters with students from another university. We found that CCS only substantially reduces the number of common word misspellings as those occurred frequently and were detected accurately. So as the conclusion, first, we propose CCS, an automated feedback tool to educate students about some aspect of code quality. The tool can be useful as students are not satisfying all code quality requirements due to human error. While using the tools for spelling correction, false results can occur, like abbreviation, contractions, concatenated words without delimiters, programming terminologies, name entities, and combination of those. According to our quasi-experiments, the tool only substantially reduced the number of common word misspellings. As for future work, we plan to include other aspects of code quality, like suggesting the replacement of inefficient code fragments, suggesting the removal of unused variable or functions, checking whether the layout is readable, or pointing out possible logic and runtime error. We also plan to reconduct the quasi-experiment on courses with larger assessments because the chances of human error is typically higher on longer programs. So currently, the tool has been further developed. It incorporates 18 additional Java code quality aspects from textile and 10 additional Python code quality aspects from Flight 8. Another round of quasi-experiments is being performed. Thank you. Further inquiries, you can contact me by email.